Hey guys, Mrs. Traver here. We're going to work on the quadratic equation, which is the last way to solve quadratics other than factoring, other than square root method. So what's nice about this method is it works for any quadratic. I don't care if it has a as 1 or a as not 1, or if it is a perfect square, if it has a b or if it doesn't. It works for everything. As long as you're in the format ax squared plus bx plus c equals 0, aka standard form, then you are in a good spot to start. So as long as we're in that format, then we can solve for our intercepts that go through the x-axis with this equation. Are you ready for it? It is x equals negative b plus or minus the square root of the quantity. Give it a big long tail for that square root, because underneath you need a b squared minus 4ac, and then this whole thing is over 2a. So there's a lot going on there. And we're going to work through some examples of these guys, and I'll show you how it all works out. So when we pull our a, b, and c, we can just plug them into the designated spots, and we'll be able to solve for our two roots. We'll work on one of them where you could have potentially factored it to prove it to you. So let me jump into our first example. Let's see. We've got x squared plus 3x plus 2 equals 0. And let's first make sure we're in standard form, and we are. Ax squared plus bx plus c equals 0. We're good there. It looks like a is 1, b is 3, c is 2. So I'll need those. A equals 1, b equals 3, c equals 2. Now I can just rewrite this equation up top and substitute all of my numbers in. So magically, let me do that here. Let me pull up my screen. All right, so I just rewrote it and plugged in the a, the b, and the c. From there, we just can do some simplifying. So let's start from the inside and work our way out. What I mean by that is let's start on the inside of the square root and simplify in there first. So I've got, let's see, 3 squared is 9, 4 times 1 times 2 is 8, and it's minus 8. And now I've got negative 3 plus or minus the square root of 1 over 2. Almost done then. The square root of 1 is itself. So I've got x equals negative 3 plus or minus 1 over 2. Since I only have numbers left, I can just simplify here. Negative 3 plus 1 over 2 and negative 3 minus 1 over 2. So I've got 2 over 2 is 1. Or I'm sorry, negative 2 over 2 is negative 1. And then negative 4 over 4 is negative 2. So my answers are x equals negative 1 and negative 2. Now notice, if we look back at the original equation we had, I could have actually factored this. I could have gone and looked at the two roots that would have made it was 1 and 2. So this actually could have been x plus 1, x plus 2 equals 0, and that would have given us the same answer. But what's nice about the quadratic, like I said, is that no matter what you start with, it will always work. So let's work on the next example. Will be a little different. All right, here's our next one. I've got negative 2x squared plus 12x equals 18. First up, I need to make sure it's in standard form, and it's not right now because I need that 18 to move to the other side. So let's make sure that we do that first. Subtract your 18 to the other side. Sometimes they try to fool you and move something to the other side. So now I can notice I've got a is negative 2, b is 12, and c is negative 18. All right, we can plug it in our equation then. Go ahead and plug it all in to your original equation way up here. So these a, b, and c into this equation, and then we'll meet up. All right, here we are. So I've plugged everything in. Let's do some simplifying on the inside like we did before. So I've got, let's see. On the inside of my radical, 12 squared is 144. And I've got 4 times 2 times 18. 4 times 2 times 18. 4 times 2 is 8. 8 times 18 is also 144. And I've got 3 negatives, so this will become a negative. Underneath my radical, those are going to go away and be the square root of 0. So that's going to end up going away. So I've got negative 12 over negative 4. So I just have one answer here, x equals 3. So again, inside my square root, that went away, and the square root of 0 is 0, so that all went away there. And I just have one answer. So notice my first one, I had two answers, -1 and -2. My second one, I only had one answer. The way that would have worked is this one could have been made a perfect square. Thinking back to our perfect squares, though, in order to complete the perfect square, we would have to do some factoring out of this -2 and then worry about what we add to each side, that it's been multiplied by the thing we factored out. So it just is a hot mess if you were going to go about it that way. Not saying you couldn't, but this is much quicker. So quadratic equation is nice because it works for every quadratic, and it's sometimes just way faster to plug it in. Let's do one more. All right, we've got -2x squared plus 2x minus 3. I've got my a term is -2, my b is 2, and my c is -3. Go ahead and plug it all into your quadratic equation next. All right, so now I've got everything plugged in. Let's simplify. So I've got -2 plus or minus the square root of, 2 squared is 4. 4 times 2 is 8. 8 times 3 is 24. And there's 3 negatives, so -24. I've got then simplifying inside my square root again. 4 minus 24 is the square root of -20 over -4. I can make this -20 look a little nicer. Let's factor it. I'm off to the side. I'm going to come over here with my square root of -20. And let's make that be first the square root of -1 times the square root of 20. That way I can use my complex number I, my imaginary number I. And then let's make my square root of 20 be not 16. How about 4 times 5? Now square root of 4 is 2, so I'll have 2I root 5. So we'll put that in place for our root 20, or root -20. All right, -2 plus or minus 2I root 5 all over -4. This looks crazy. The very last thing I do want to do, though, is simplify this 4 that's underneath here. -2 divided by -4 is 1/2. So let's just make that be a 1 plus or minus 2 over 4 is a -2. So we'll leave this guy negative. So we'll have I root 5. That looks a little nicer. So we still have two roots. These are two complex roots. So taking a step back, I want to look at the 3 different types of answers we had. On the very first one, we were able to get 2 real roots. On the next one, we got 1 real root. And on the last one, we got 2 imaginary roots. Or I should say 2 complex roots. So what makes that happen is what's inside the square root. So let's look at that a little bit more in depth. So looking at the types of roots, what we need to look at is the discriminant, is what it's called. So what's inside the square root is called the discriminant. And what's special about it is we can kind of classify it into 3 different things. If the discriminant is positive, let's think about what happens. So that was like the first one. If we have a positive number underneath the square root, so what I mean is when we simplify b squared minus 4ac, if my thing that's circled in blue is a positive number, then we'll be able to take the square root of it, or at least simplify the square root and get real answers. So in this situation, I'll have 2 real roots. And that'll look something like a regular parabola where it crosses the x-axis twice. Nothing crazy there. I'm going to finish the discriminants on the next video here, so I'll match up with you in a moment.